Now, let's come back to the theory again here. Look at the formula. It says x equal to minus b plus minus square root of b square minus 4ac divided by 2a. Here b and a are outside the square root, but b square minus 4ac, this whole item is inside the square root, right? We also have an information that square root of a positive number, this will be real number, whereas square root of a negative number is imaginary number or a complex number, right? So we need to identify, or we need to put some conditions here also on the basis of this b square minus 4ac, right? Let's do that one by one. Okay, the first condition, let's say case 1, we say that if b square minus 4ac is greater than or equal to 0, we say if b square minus 4ac is greater than 0, what will happen? Then roots are real, right? Real and distinct. Okay, real and distinct. This is very important information. So if b square minus 4ac is greater than 0, then roots are real and distinct. Now here, what we are talking about is the nature of roots, right? We are talking about the nature of roots. What type of roots we will be getting for a given equation, right? Before going ahead, just one more thing. There is a word discriminant coined for b square minus 4ac. This b square minus 4ac, sometimes in the books it is also written as d, capital D. It is actually called discriminant. So the D is the first letter of the word discriminant, right? So this expression b square minus 4ac is called discriminant, not delta. Okay, and why discriminant? Because it describes the nature of roots, right? So the first case, if b square minus 4ac is greater than 0, then the roots are real and distinct, right? Now even in this, there are two distinct situations. Okay, so if I have, let's say, within case 1, let's say first situation, if I have b square minus 4ac is equal to a perfect square. A perfect square, like 1, 4, 9. So what we are saying, b square minus 4ac is already greater than 0. Within this, if b square minus 4ac is a perfect square, then what will happen? Then the roots are anyways already real. So roots are rational, right? Rational and distinct. Okay, look at this carefully again. I'm saying that we already have b square minus 4ac greater than 0. In this, the roots are real and distinct, right? Now, even in this situation, if b square minus 4ac becomes a perfect square, then the roots are rational and distinct, right? This is the only case where factorization is possible. Right? So remember the question that we did with factorization? All those equations, quadratic equations, were following this condition. So this is where we can use factorization method for quadratic equation. Right? In fact, this is the only case. Okay? Factorization method to solve. Alright. Now let's take the second condition. What if b square minus 4ac is greater than 0 but not equal to a perfect square? Then what will happen? Right? Now you see, if it is not a perfect square, see, if it was a perfect square, what would have happened? The root would have gone out, so we would get a rational number. Whereas if b square minus 4ac is not a perfect square, then root will remain there, root will not go out. Now if the root does not go out, what will happen? The roots will be irrational, right? Instead of rational, now it will be, then we can say, then the roots are irrational. Alright. Now, when the roots are irrational, we have already seen in the previous case that in the last 2-3 questions that we have seen, when the roots are irrational, they are conjugate. You remember conjugate? What is the meaning of conjugate? We saw in one of the examples that we had the roots as, for example, I'll just recall, it is 5 plus 2 root 3 and 5 minus 2 root 3, right? So this is the example of conjugate root. So whenever the roots are irrational, they must be conjugate. Irrational means things like root 3, root 2, root 5 and so on and so forth. Okay, and this is the situation of conjugate pairs. So irrational and conjugate pairs, right? What is the meaning of conjugate? Look at this carefully. If it is one root is a plus b, the other root has to be a minus b. If one root is a minus b, other root has to be a plus b. Remember, sign has to be changed only for the part which is irrational, right? So it is 5. If one root is 5 plus 2 root 3, the other root has to be 5 minus 2 root 3, right? So remember two conditions from here. If b square minus 4ac is a perfect square, then the square root sign will go away and we'll get a rational root, a pair of rational roots, right? If b square minus 4ac is not a perfect square, then the roots are irrational and conjugate pairs, the examples of which we have already seen, right, in the previous cases. In the last 3 questions we have seen that. Okay, right. Now let's take up the next condition or next case. Now let's take the next case. Let's say case 2. This is a very interesting one. Okay, it says if b square minus 4ac is equal to 0, then what will happen? Understand from this formula, if b square minus 4ac is equal to 0, then this whole thing goes away completely, right? Then this whole thing goes away completely. Then the minus plus will not make any sense. The only thing that will remain is minus b divided by 2a, right? So if b square minus 4ac, then there is only one root, right? Because then this whole part becomes 0. Plus and minus separately will not give any different roots, right? So then the roots are real and equal. This is a very important condition. Real and equal, right? So if a quadratic equation has equal roots, that means b square minus 4ac is equal to 0, right? Let's look at some examples. If I give you a situation like this, now let's take a look at this question. It says if this equation 3x square minus 4x plus 6p equal to 0 has equal roots, find p. What do we do from here? From here what we can see, if it has equal roots, then we can directly apply this condition. See, if the roots are equal, that means this condition must have been satisfied. Here a is equal to 3, b is equal to minus 4 and c is equal to 6p. Please be careful in picking up the value from the equation. Now the condition is b square minus 4ac should be equal to 0. Okay, so we straight away put the values here. In place of b we put minus 4 whole square minus 4 into, in place of a is 3, in place of c it is 6p. That should be equal to 0. So it is 16 minus 4 3s are 12. 12 into 6 is 72. P, that is equal to 0. Okay. So further if you solve, you will get 16 is equal to 72p. That means p is equal to 16 divided by 72. If you cancel by 8, 8 2s is 16, 8 9s is 72. So that means the value of p in this question is 2 by 9, and that is the answer of this question. Right? But the basic crux of this question was to identify that for equal roots, the only thing that you need to do is put b square minus 4ac equal to 0 after identifying the values of a, b, c correctly. Alright. Now, suppose in this question, if it said also find the root, then what will you do? Let me do this. Suppose if we already have the value of p here, so if I have to solve, what should I do? I should take 3x square minus 4x plus 6 into, the value of p is 2 by 9, that is equal to 0. So 3 cancels 3 times and 6 2 times. So we will have 3x square minus 4x plus 4 by 3 equal to 0. Now multiply by 3, it becomes 3 into 3, 9x square minus 12x plus 4 equal to 0. Now if you look at this closely, 9x square is 3x whole square minus 12x is 2 into 3x into 2 and 4 is 2 square. That is equal to 0. So this gives us 3x minus 2 whole square equal to 0. That is 3x minus 2 equal to 0. That is x equal to 2 by 3. Right? See, remember, there will be only one root. And if there is only one root, that means always it will happen that this quadratic expression boils down to a simple square expression. 3x minus 2 whole square expression. Right? So the value of x in this question is 2 by 3. Okay. Let's take a couple of more examples and then we'll go ahead to case 3. Now let's take up some questions on this concept of quadratic equation having equal roots. We already have done the condition that it says b square minus 4ac equal to 0. Right? This is the condition. We'll directly apply this. Remember, b is the coefficient of x, right? A is the coefficient of x square and c is the constant term. Now here, you see, in place of b it is not b, it is minus 5b. Right?
So in the formula that we have b square minus 4ac equal to 0. Here in place of b, it is not b, it is minus 5b. So it is minus 5b whole square minus 4 into, in place of a it is 6 and in place of c it is 8. This is equal to 0. Alright, so it is b square minus 5b whole square minus 4 into a is 6, c is 8. So it is 25b square minus 4 6 is 24, 24 8s is equal to 192. Alright, that is equal to 0. So from here we can see that b square is equal to 192 divided by 25. Okay. Now 192 can be factorized as 64 into 3 divided by 25 is 25. Now b square, so this means b square is equal to 64 is 8 square into 3 and 25 is 5 square. So this gives us very clearly that b is equal to, if you take the square root, 8 square will become 8 root 3 and in denominator it will be 5. So answer of this question is just 8 root 3 upon 5. Alright. Now let's take one more question on this. Now let's take up another question. It says if the equation 3x square plus 6x plus 7b has equal roots, it must be equal to 0, has equal roots, find b. Now in this equation, as you can see, a is 3, right, coefficient of x square, b is plus 6, coefficient of x, and c, the constant term, is 7b, and this b we have to find. So be careful, apply this formula, b square minus 4ac. So in place of b it will be 6 square minus 4, in place of a it is 3, and in place of c it is 7b, right, that is equal to 0. So from here we have 6 square is 36, minus 4 into 3 is 12, 12 7 is 84b, that is equal to 0. So here the unknown that we have to calculate is b. So we get 36 is equal to 84b. So this gives us b equal to 36 upon 84. Now 12 cancels 36 3 times and 84 7 times. That means the value of b in this case is 3 by 7. Right? So this is the answer of this question. Right? Now suppose in this question, if I add one more thing, right, let's say also find x, right? Suppose if I have to find the value of x in this equation, so what do we do now? So here we have already calculated the value of b, put it here and solve it. Alright, so let me take some space. So now that we have calculated the value of b, we put it here. The equation was 3x square plus 6x plus 7b equal to 0. Alright, now we put the value of b here. B is 3 by 7. So clearly from here you can see that 7b is equal to 3. Right? B is 3 by 7. So 7b will be 3. So in place of 7b we put 3. So it is 3x square plus 6x plus 3 equal to 0. Now this is a very interesting situation. If you divide by 3, this equation becomes x square plus 2x plus 1. Right? Now this is x plus 1 whole square is equal to 0. That is x plus 1 equal to 0. Alright. And this means x is equal to minus 1. That means the answer of this equation is x equal to minus 1. Alright, so this was a good question. Okay, so sometimes we have to find the value of the unknown and sometimes we also have to find the value of x. So just put it back in the expression and solve it to find the value of x. Alright.
Now come back to this situation again. Now let's take up the third case, that is case 3. If b square minus 4ac. Now we have already done b square minus 4ac greater than 0. We have already done b square minus 4ac equal to 0. What if b square minus 4ac is less than 0? Now what will happen? Now let's see. If this b square minus 4ac is less than 0, that means it is negative. Now square root of a negative number is not defined. It is imaginary number. Okay. Right? So square root of a negative number. If b square minus 4ac is negative, that means b square minus 4ac is equal to a negative number. That means square root of b square minus 4ac will be square root of a negative number. Now square root of negative number is imaginary number. Alright, imaginary number. That's it. This means that in this case we can say that the roots are imaginary. And here also, whenever the roots are imaginary, they are conjugate. Okay, so I just explained the meaning also, conjugate. Okay, Now before going ahead, though we have done it in numbers chapter also, but if you don't remember, I'll just mention this. Square root of negative numbers cannot be simplified, right? It can be simplified only to a certain extent. Let's look at that extent, what it is. Suppose we have square root of 9. We know it is 3, right? But if we have square root of minus 9, what can we do? What we can do is, we can write it as square root of 9 into minus 1. Now square root of 9, that can come out 3. Square root of minus 1, nothing can be done of this. Okay? So what we do, we assume that root of minus 1 is I. I stands for the first letter of the word imaginary. Right? So root of minus 1 is I. From here you can see that I square is equal to minus 1. From here you can see that I raised to the power 4. If you further square it, it will become minus 1 square, which is 1 or plus 1. Alright. You can also see that I cube is equal to I square into I. I square is minus 1 into I becomes minus I. Right. So it is just the description of I. For once you should know that I is equal to root of minus 1. I square is equal to minus 1. That's it. Right. I raised to 4 is equal to 1. I cube is not necessary, but just to show I have given you all the 4 examples. Right. Okay. Now 3 root of minus 1 can be written as 3I. Remember that I is an imaginary number, so it won't be useful for any kind of mathematical operations. Okay. It is not useful for any value assumption, but at least the presentation can be done as 3I. So whenever we get a square root of negative number, we express it in terms of I or iota as it is known in general. Okay. Let's take an example. Suppose we have x square minus 8x plus 41. Suppose we have this question, x square minus 8x plus 41. Now 41 is a prime number. 1 into 41, only one possibility. After adding, we should have got 42, whereas it is 8, so we cannot factorize it, right? So we'll apply the formula. What happens if we apply the formula? Here a is equal to 1, b is equal to minus 8, c is equal to 41. Alright. So this means x will be equal to minus b. I am directly putting the values here. Minus b, so it is minus of minus 8. Plus minus root of b square, that is minus 8 square, minus 4ac, so 4 into a is 1 and c is 41, divide by 2 into a, so a is 1. So we have x is equal to minus of minus 8 is 8 plus minus square root of 8 square is 64 minus 4 into 41. Now 4 into 41 you can see it is 164 divide by 2. So it is 8 plus minus 64 minus 164 is minus 100. So it is square root of minus 100. Divide by 2. Now it is 8 plus minus. If you take out 100, it will be, you can write this as 100 into minus 1. Divide by 2. Okay. So I'll write it here. From here we can see this x is equal to 8 plus minus. 100 comes out and becomes 10. Root of minus 1 divided by 2. Right. Now this root of minus 1, for the sake of simplicity, we can write it as I, right? So it is x equal to 8 plus minus 10I divided by 2. If you divide by 2, it will be x is equal to 4 plus minus 5I, right? As you can see, they are also in conjugate pairs, right? We have said that they are conjugate pairs. How? Let's see. One root is 4 plus 5I. The other root is 4 minus 5I. Right? The rules are same as we had in irrational numbers. For conjugate numbers, the rules are same. How? If we have 4 plus 5i, the other number has to be 4 minus 5i. Right? These imaginary roots will always be in conjugate pair. Similarly, if one root is 4 minus 5i, the other root has to be 4 plus 5i. For conjugate, I repeat, what you have to do is change the sign of one of them. Which one of them? The problematic one. Right? For example, imaginary is the problematic. Right? So change the sign of problematic, that is imaginary term. Similarly, in irrational also, we have changed the irrational term sign. Okay. So this is what we can do in imaginary roots.